Now, continuing the preceding video, we haven't addressed the idea of whether this is continuous or not. Now, continuous just means that the value of the function doesn't change by a whole lot if you just change the value of x by a little tiny bit. Well, in any little tiny bit of the x-axis, you have both rational and irrational numbers. So if you go into any little tiny bit of the x-axis and look at the value of the function for a rational number, it's going to be significantly higher than it is for an irrational number within that tiny increment. Okay, so any tiny part of the x-axis, you have a function whose values are jumping between the value you get here and the value you get down here, so that the values jump around infinitely many times within any small interval, so that any tiny interval contains rational and irrational numbers, so the values jump around like crazy. Now I can make that much more specific and mathematically concise and precise, but there's no point in doing it right now. You should be able to see that in any tiny interval here, if you accept that there are infinitely many rational numbers within this interval and infinitely many irrational numbers within this interval, then between these two values of x, you've got a lot of values between, let's say, here and here, as well as a lot of values between here and here on this branch of the, or in this portion of the function. So the function keeps jumping around between values here and values here, even on that little tiny interval, and no matter how tiny you make that interval, you still have an infinite number of jumping between values here and values here, so that the values of the function are not necessarily close together if the two values of x are close together.